Okay, so for the first one here, to find the volume, our base is this circle here, and the circle has a diameter of 6 inches. So to find the area of our base, it's pi times 3 squared. 3.14 times 3 squared. Giving us 28.26 inches squared for the area of our base. So then the volume is that area of the base, 28.26 square inches, times that height. Remember, the height is not necessarily up and down, it's the distance between the bases, which is that 10 inches. So 282.6 inches cubed.
I was just trying to figure out half the circumference of a circle yesterday because I was spray foaming a like an arched corrugated shed.
Yep. Yeah, and unfortunately, most of those are not even a true half circle. So it gets to be even a bit more complicated than that, but they're close enough. But yeah, you have to find that half circumference and then multiply by the length to get your surface area there. For number 2 here, we need to find the area of the base. The base is going to be this trapezoid because that's what gets pulled through to the other end. That trapezoid has bases of 8 feet and 16 feet. We're going to average them together and multiply by that height of 6. So what is that? 72 square feet. The area of our base. So our volume is then found by taking that area of the base, 72 square feet, times our height, which is the 20 feet, which is 1,440 cubic feet of volume. Did you get yours figured out okay, Chase, yesterday, or
The get what figured out yesterday?
the area for that spray foam?
Oh, I I mean it was a set job price, so we weren't really too worried about it. I
Okay,
just didn't finish with it.
sure. Well, let's take a look at it. Do you remember the dimensions at all?
Yeah, it was 39 by 30 shed or 39 by 39.
39 by 39. So
Yep.
diameter of 39 across here, and then 39 this way.
Yep.
Okay. And this will be approximate because, like I said, most of those are not a true half circle.
Yeah,
But
but it's close enough.
it is very close. Jewel, what thickness were you spraying the foam at?
2 inches.
2 inches, okay. So we'll take a look at that too then. So yeah, the first thing you'd have to find is this distance around here, which is pi times 39 would be the circumference of the whole circle, and then divided by 2. So that's 61.23 feet around that half circle. Then you would just take that times that length of 39 feet, giving us an area of 2387. Now on a job, I would just round that up to 2390 or probably even 2400. And then
Yep.
2 inches, now all the other dimensions are in feet, so I have to do 2 over 12 for feet. So this was square feet, so this is going to turn this, multiplying by 2/12 of a foot, is going to make that cubic feet. So yeah, just under 300 cubic feet. Yeah, I would probably, figuring out materials, I'd probably account for at least 400 cubic feet of foam there.
Yeah, look, yeah. Yeah, no, I just I was gonna figure it out last night and I just got so tired I didn't. But
Sure. What does a canister cover? Do you know?
A set of chemicals?
Yeah, because you have what, the two canisters you got to mix together, don't you?
Yeah, they're two part. Well, we went through one set, which is two 55-gallon drums, and a third
Okay.
of a set,
Okay.
and we didn't quite finish it, so we got to go back with like another two-thirds of a set or a set.
Okay. So a couple hundred cubic feet is really about all you get out of one set then.
Yeah, probably.
Sure. Now, do you prep the surface on something like that? Do you prep the surface so it sticks, or does it stay right on that steel pretty well?
It sticks to the steel pretty well, but the thing you really want to make sure is that you don't have like excessive dust on it,
Sure.
because dust, it'll just act like a barrier. It'll stick to the dust and then it'll peel right off.
Right off. Sure.
So
Well, I know
you
a lot
don't,
of those prefab sheds, the bolt together sheds.
yeah,
Um, the steel is oiled when it comes from the factory,
yeah.
and so I know you got to deal with that too. That oiled surface, it won't stick to it all, or at least not very
Well,
well.
well, I told the people, I was like, if this has any sort of lubricant or oil or anything, I was like, make sure you pressure wash this before we come and spray it.
Sure.
So they actually went through and they pressure washed and cleaned the whole thing. So
Ah, good.
yeah.
Yeah, I've always wondered if you could, because you got all those bolts sticking through anyway. Because I've mounted some garage doors, overhead garage doors, and sheds like that. And
Yeah.
so you've got that stub of that bolt sticking out, so you can always, you can add a piece of a strap iron or angle iron just by putting a second nut over the end of that bolt, so you have something to mount to. I've
Yeah,
always
actually
Go
the
ahead.
the gaps and cracks in the bolts and stuff, they all make it easier for it to hold on to.
Sure,
So yeah, I mean that's one of the things that is kind of nice to have is the extra bolts and stuff sticking out because it grabs it better.
sure. Yeah, I've always wondered if you were gonna put a thick layer of insulation on, if you could just hang chicken wire or something off of those bolts just to give it a mesh to just go into, just to make darn sure it doesn't come loose. But
Oh yeah, yeah, definitely. If you want to like hurricane proof that place, yeah.
sure,
But they're happy with it so far. I mean, it's way. I mean, you could walk outside, knock on the part that we didn't spray,
and you
and
hear
then
it.
yeah, it would just sound like you're knocking on tin, and then you knock on the part we sprayed, and it sounds like you're knocking on a wood door.
Sure. Yeah, I've
So
got a friend of mine that I started helping him fix up his shed. Like he has one of those, and he unfortunately never finished. He was going to wall off a portion of it to make a heated shop and never got it done. Well,
yeah,
basically the shed filled up before he got around to getting the walls all done.
yeah. I mean, the biggest thing is just a lot of times we tell people if they're building a new building, don't put the drywall on before we come.
Oh yeah, definitely.
Otherwise, we have to drill holes through all of their drywall.
Yep. Well, and then you're never totally sure if it fills up the cavity or not.
Yeah, yeah. I mean, you pretty much just spray it in there till it comes shooting out at you.
Yep. I,
Yeah.
does that have much pressure? If you overfill, will that pop the drywall right off then?
Um, it could possibly if you overfilled it like really bad.
Sure.
Um, but it really doesn't have a lot of actual expanding pressure.
Okay.
Um, we actually that shed that I was doing, the guy wanted the door filled and it was a corrugated door, so I told him put a piece of sheet metal on both sides and drill holes in opposite cavities.
Sure.
And so he did that, and I filled his door, so he's got an insulated door now too.
Nice. Yeah, I know, like, the great stuff foam that you buy in the can at Menards or whatever. People don't realize that that's actually a highly expanding foam and a high pressure expansion. So
Yeah.
I have seen people fill the cracks around their doors or windows and then come back and they can't open their door because it swelled it, pushed it shut so much, or they get their door open and they can't shut it.
Well, you're supposed to use it as a sealer, not
Not a
just
filler. Yeah.
yeah. I mean, it can fill gaps and cracks and stuff, but you're trying to use it as a sealer.
Yep. Yeah, and people don't realize. I mean, I've seen one door I saw. I bet the frame was bowed in almost half an inch. There was no way you were getting that door shut again until you dug all that stuff out and pressed the frame back out.
Yep. Take a long knife and cut a sliver out of the center of it.
Exactly. Well, I suppose I better cover some math here for us.
Yeah.
So we've talked about all this volume. The next step is to talk about surface area. We talked about it briefly with the cylinder, and we're going to use that same model for our other shapes. So we have our base. We use that area of the base to find our volume. Let's just stretch our base up here. So let's say that our base here is 8 inches by 6 inches, and let's give it a 10-inch height. So the area of our base was the 8 inches by 6 inches, giving us 48 square inches. And our volume was that 48 square inches, the area of that base, times our height of 10 inches. We got 480 cubic inches. For surface area, now it seems a little weird to do it this way with a box, but we'll appreciate it when we get to the other shapes having defined it this way. The surface, a box, we could just do all 6 rectangles and add them together, but not all shapes are that easy. So we're going to divide the surface area into 2 distinct pieces. The area of the bases. So for this, we already found the area of one base is 48 square inches, but there is a second base. It's also 48 square inches. Number 1 on bottom, 1 on top. And then something called lateral area. We mentioned this word when we talked about the cylinder a week or so ago. The lateral area is that area that connects the bases. Remember the cylinder, the bases were the circles on either end. The lateral area were those sides that connected the bases. On the cylinder, we sliced it down the side and we unrolled it to make a rectangle. We can actually do that with every type of regular solid that we work with. We can cut this down a corner and unfold these surfaces around here to make one large lateral surface. The height is still 10 inches. The length here, we've got 8-inch side, then we got a 6-inch side, then another 8-inch side and back, and then a 6-inch side on the left over here. So in other words, that length is just the perimeter of our base. So to find lateral area, that's the first thing we find is the perimeter of our base. So in this case, 8 inches plus 6 inches plus 8 inches plus 6 inches, which gives us 28 inches. And the lateral area is simply the perimeter of that base times the height. So it's going to be 28 inches times that height of 10 inches, giving us 280 square inches. And now to get our surface area, or total surface area, if you want to call it that, we add those 3 dimensions together. So our surface area is 376 square inches. Now again, with a box, you could have just found all 6 of the rectangles. Actually, 3 rectangles, because they're the mirror image on the other side, and added them together. But when we get into shapes like our cylinder, like we saw before, let's use our cylinder that we had for our opener here this morning. So this is 6 inches across here and 10 inches up here. Our base is this circle over here, so the area of our base was pi times 3 squared. Remember, the diameter is 6, so the radius is half of that. Pi times 3 squared is 28.26. That's inches squared. And of course, there's going to be 2 of them. This is an identical circle on the other end. And to get that lateral area again, we need the perimeter of the base. Well, the perimeter of the base is just the circumference of the circle, which is going to be pi times 6. Give us 18.84 inches. And of course, now we can tie that into the lateral area. Is the 18.84 inches times that height of 10, giving us 188.4 inches squared. And we have to add those 3 together. So what do we get there? 56. 244.92 square inches of surface area. And it can be any of our other shapes. We did one the other day with a triangle as a base. Looks something like this. So our base is this right triangle here. We can find the area of our base. Just 12 inches by 5 inches. Divided by 2 because it's a triangle. Excuse me. Giving me 30 square inches. And of course, there's one at the other end down here that's also 30 square inches. So then our lateral area we need the perimeter of the base. So we've got 5 and 12. We need to find that side. So to find that side, we can use a squared plus b squared equals c squared. So here we have 5 for a, so 5 squared plus b is 12, so 12 squared equals c squared. Well, 5 squared is 25. 12 squared is 144. 25 and 144 is 169. Take the square root of each of those sides. Hey, there we got you guys.
Sorry, we just joined in.
Door was locked.
Oh, geez. Sorry about that.
Computer shut off and all sorts of fun.
So we were working on an example here. I was wondering why nobody was logged in yet. We got Chase has been in here for a while. But anyway, we've been working on this example here of surface area. And we've defined surface area to be the area of the bases plus what's called lateral area. And the lateral area, if you look at what we did with our cylinder last week, is the perimeter of the base times the height. Remember, we found the circumference around the circle here. In this case, that's a 6-inch diameter circle, so that circumference was 18.84 inches. Then we multiplied by the height, the distance to the other base of 10 inches. So 18.84 times 10 is 188.4 square inches. That is the lateral area of that cylinder. That's the part that connects the two circles. If you think back to the sheet of paper, the bases are the circle on each end. Cut it down the side and unroll it. That's the lateral area. And on these regular solids, that lateral area can always be turned into a rectangle like that. The lateral area is a rectangle whose area is just the perimeter of the base times the height. So on this one, we found the area of the bases. We have those 5 by 12 triangles, so it's 12 times 5 divided by 2 give us 30 square inches. There's one on the other end, so we had a second one. So we've got the area of our bases right there. So now we're working on the lateral area. And to find the lateral area, we first need the perimeter of the base. And we found we had 5 inches here and 12 inches here. We needed to find the other side, side C up here. Well, since it was a right triangle, it was a squared plus b squared equals c squared. So 5 squared plus 12 squared equals c squared. And calculating through that gives us that this hypotenuse here is 13 inches. So our perimeter of the base was 5 inches plus 12 inches plus 13 inches. Giving us 30 inches is the perimeter of our base. So our lateral area is the perimeter of that base, 30 inches, times the height. And remember, the height is the distance between bases. That's this 20 inches here. So 30 times 20 is 600 inches squared. So our surface area of this is found by adding up the area of the bases plus the lateral area is 660 inches squared. That's the surface area, or sometimes called the total surface area, TSA. So let's look at a little bit more of a strange shape here. So for this shape here, we're going to say that this is, let's go 12 millimeters here and 20 millimeters all the way across. And we'll go 20 millimeters here. And let's do the whole gamut. Let's find the volume and the surface area here. So let's define the volume. We'll start off with the area of our base. Now this is not going to be a simple area for our base here because the base is that rectangle and those 2 half circles. This shape here is the base. So I'm going to cut it here like that. I have this one section here that is my rectangle. So that first section is a 12 millimeter by, we need to know this dimension across here. Well, the difference between the 12 and the 20 is 8 millimeters, and we know that has to be split 4 millimeters on each end. That makes the radius of our circle 4 millimeters, which makes this dimension 8 millimeters. It's a diameter. So 12 millimeters times 8 millimeters, 96 millimeters squared is the area of that base. Or that piece of the base. And then we have part 2. Part 2, I'm going to actually just piece together the 2 half circles to make one full circle with a diameter of 8 or a radius of 4. So part 2 is pi times 4 squared. So pi times 4 squared is 50.24 millimeters squared. Adding up to an area of the base there of 146.24 millimeters squared. So now my volume is actually pretty simple off of that. Take the area of my base, 146.24 millimeters squared, times my height. Remember, height again is the distance between the bases. So that's that 20 millimeters, which is going to be 2924.8, I believe. 2924.8 millimeters cubed. I'm going to double check that just to make sure. It is true. Okay. So there's our volume. Now for surface area, we have part of the work done already because for surface area, we start out with the area of the base. We found that up here. Actually is the 146.24 millimeters squared. And this does have a second base on the other end. So another 146.24 millimeters squared. Now we need to look at that lateral area again. Come on. So for our lateral area, the first thing we need is the perimeter of the base. So looking at our base here, we have straight sides of 12 and 12. And then we've got these two arcs, half circles. Again, we put them together to make one circle that has a diameter of 8. That circumference is just pi times 8, or 25.12 millimeters. So that adds up to a total perimeter of that base going around here of 49.12 millimeters. So then my lateral area is the perimeter of the base, 49.12 millimeters, times that height of 20 millimeters again. Which is, what is that, like 980 something? 982.4, I believe, millimeters squared. So we add that all up. Get 1,274.88 millimeters squared as our surface area. Any questions on that? Yeah, go ahead.
When you do the perimeter base, you only got to do one side, not the other side?
Yep, you just have to take one of the bases and do the perimeter of one of the bases. If you think about it, go back to that cylinder. The base is the circle on either end, right? So if I find the circumference of one circle, when I unroll it, it's the circumference of that circle that is the length of our rectangle. The height here is still just the height of that cylinder. So the height hasn't changed, but the length of the rectangle is just the perimeter of the base. Well, it's break time. Does anybody need a break, or do you guys mind if we just pound through and get done a couple minutes early?
Go on.
Let's just keep going. Good. Okay, so that surface area on our solids, or by regular solids. What I mean by a regular solid is, as a base on one end, then an identical base on the other end. So, as strange as this base might look, this is a regular solid because it's the same shape on either end. Oh, let's give some dimensions here. Let's call this, let's go 8 inches across here. We'll go 4 inches here. We'll make it work. We'll go 6 inches here and here. And this height will go 10 inches. So let's go again. Let's do the whole gambit. Find volume and surface area. For volume, the first step is going to be the area of the base. Your base is this shape down here. I'm going to give you guys about a minute to see if you guys can come up with the area of a base on your own here. Then we'll go over it. So I'm going to cut that into 2 pieces. That first piece here is an 8-inch by 6-inch rectangle. So it's 48 square inches. The second piece here is 4 inches by, well, 8 minus 6 makes this piece 2 inches. That's 4 inches by 2 inches, or 8 square inches. Adding up to a total area of that base of 56 square inches. That's the area of our base. I'll have you go to the next step, find the volume. I'll give you about half a minute to find the volume. So if you recall, the volume is just the area of the base times the height. So we have the area of the base that we found here, the 56 square inches. The height is just the distance between the bases, in this case 10 inches. So that's 560 inches cubed. You might find that I use a lot of heights of 10 and 12 or 10 and 20 inches just because they're easy to multiply by. So then our next step for surface area. We start out, we already have the area of the bases. Each of them is 56. Now we have to count that twice because if we're looking at the surface, there is an area down here that is exposed, and the base up here is also exposed. Excuse me. For lateral area, lateral surface area, first step we need to find is the perimeter of the base. So I'm going to give you guys about a half a minute, see what you can find for the perimeter of the base. So for perimeter, I can just pick a corner if I want to and work my way around. I've got 8 inches plus 4 inches plus, we found that one to be 2 inches plus this one here would be 6 minus 4. That's also 2 inches plus 6 inches plus 6 inches here. Should add up to 28 inches. So we have a perimeter of the base of 28 inches, which means lateral area is the perimeter of the base times the height. We've got the perimeter of our base of 28 inches times our height of 10 inches, which is 280 square inches. We add the three of those up to get a total surface area, 392 square inches. Well, as we said, those are what we call regular solids because they have a base on one end and an identical base on the other end. Irregular solids would have different shaped bases. Most irregular solids are rough to work with. I'll say that just flat out. We are going to work with some very special irregular solids that aren't so bad. For example, something like this. Let's look at a pyramid. So we're looking at a pyramid here that has a base of 16 inches by 16 inches, a square base, and a height of 15 inches. Now, obviously, this does not have two equal bases. It has a base on one end, and then it goes to a point. And that's a class of shapes, pyramids, cones, that all come together that have similar, they actually have the same formulas to solve them. For the volume here, let's once again find the area of the base. Well, this base is pretty simple. It's a 16-inch square. So 16 inches times 16 inches, 256 square inches. Now the volume is going to, just like we took the triangle for area and we related it to a rectangle, we're going to relate the volume of this to a box. But if I cut a box in half, what I end up with is not a pyramid. I end up with something like this. It's a wedge. It's still bigger than a pyramid. To make that a pyramid, I would have to cut it a second time across here like that. But what I'm snipping off there is not half of what's left, because what I was snipping off was just the thin part of the tip up here, the tip of that wedge. So we know that the pyramid is less than half of the whole box, but it's more than a fourth of the whole box. Now, without calculus, I can't show you why the number comes out the way it does, and we're not getting into calculus. But this is one you'll have to take my word on. Like I said, it's between half and a fourth of the whole box. It's actually a third. The volume is the area of the base times the height divided by 3, or times 1/3. We have 256 inches squared times that height of 15 inches, and we'll divide by 3. So I believe that gives us a volume of 1,280 cubic inches. For surface area, there are a couple of adjustments. The first of those adjustments, the area of our base is 256 square inches. We still need that, but there's only one of them. The other end is a tip. There's no area. A point has no area to it. So we only need the area of one base for the pyramid. For lateral area, we still need the perimeter of the base. Here that's just 16 inches plus 16 inches plus 16 inches plus 16 inches. Otherwise known as 64 inches. That's the perimeter of our base. Just going around that 16-inch square. However, in all of our other shapes, that lateral area went straight up and down on the sides. Here, that lateral area is sloped. It doesn't go straight up and down that 15 inches of height. It slants in. So we have to find the length of that slope there. This dimension right here. We know that this is 15 inches here going straight up. And we know that if this is a regular pyramid that hits in the center, which means this dimension is half of our 16 or 8 inches. So we have a right triangle that has legs of 15 inches and 8 inches, and we're trying to find the hypotenuse. So it's a squared plus b squared equals c squared. So 15 squared is 225, plus 8 squared is 64. That adds to make 289. And we square root it. You get that c is 17 inches. Well, that is what we call the slope length, or the slope height, slant height sometimes called. So s equals 17 inches here. That is our slant height. So the perimeter, or the lateral area, I should say, has to be adjusted. It's the perimeter of our base times not our height anymore, but that slant height. And you'll also notice all the shapes on that lateral area are now triangles, not rectangles anymore. Find the area of a triangle, you got to divide by 2. So the lateral area is now the perimeter of the base. Instead of times the height, it's times the slant. And we have to divide it by 2 because it's triangles. So the 64-inch perimeter of the base, 17-inch slant, going to be divided by 2. What is that, 544 square inches for our lateral area. So to find our surface area, we add those up. We get exactly 800 square inches for the surface area of that pyramid. Let's talk about cones. Cones are very similar to our pyramid. Find the volume. We once again start out with the area of the base. Well, the base here is a circle with a diameter of 10, so a radius of 5. So that area of that base is 78.5. These are measured in feet, so that is square feet. So our volume, once again, is the area of the base times the height. Now we're still using the height for the volume, and of course divided by 3 because it comes to a point. The way I always remembered it is to get from a rectangle to a triangle for area, you divide by 2 because they're two-dimensional. You get from a box to a pyramid or a cylinder to a cone. For volume, you divide by 3 because it's three-dimensional. We got the area of our base, 78.5, times our height of 12. Those are both in feet. Divided by 3. I believe that's 314 cubic feet. It is. So there's our volume, 314 cubic feet. For surface area, we already have the area of our base, 78.5 square feet up there. And there's only one of them because the other end is a point. So we only have one base that we need the area of. Well, for lateral area, we need two things. We need the perimeter of our base. This is a circle, so the perimeter of our base is just the circumference of that circle, which is pi times the diameter of 10 feet, 31.4 feet. We also need to find this slant here. Well, we know this is 12 feet. That's our height. This should hit the center of the circle, so we know this is half of our diameter, or the radius, which is 5 feet. So we know that 12 squared plus 5 squared equals that slant height squared. So 144 plus 25 equals the slant squared. 169 equals the slant squared. Slant is 13 feet. So remember, the lateral area is the perimeter of the base times the slant divided by 2 because it comes to that point, so it's kind of like a triangle. 31.4 feet times 13 feet divided by 2. $204.1 square feet for the lateral area. Here's a total surface area of 282.6 square feet. What do y'all think? Fun and games? This stuff to me isn't so bad, but I'm a visual person. One of the best skills that you can have in engineering and in math is the ability to, in your mind, take things apart and put them back together. And this is where that ability really shines. That's something you struggle with, and it's more and more common now to have students that are not good at that because we don't have to anymore. We've got video screens for everything. So you don't have to visualize stuff. So that skill is something that is weakening in the younger students coming up through. So if that is something you struggle with, it's something you need to work on or figure out how to cope with. That visualization ability is really priceless in the trades. Any of your trade fields, to be honest. Well, let's put something together here just to have some fun. So let's call this 16 feet across here. We'll go 20 feet of height here. Additional 6 feet of height here. So this is a cylinder with a cone sitting on top of it. Volumes, when we have a compound shape like this, are strictly additive. That means we can just find the volume of each piece, add them together. So piece 1 will be my cylinder, piece 2 will be the cone. So for piece 1, I start out with the area of that base. This is going to be pi times 8 squared. The base, of course, is just this circle here. So pi times 8 squared is 200.96 square feet. The volume, of course, is that area of that base, 200.96 square feet, times that height of 20 feet. Which I believe gives us 4,019.2 cubic feet. I'll double check that. It is. Now for the second piece up there, the base is this circle. Well, that's just the same as the circle we had down here. So the area of the base hasn't changed. It's still 200.96 square feet. So that volume is going to be the area of that base, 200.96 square feet, times that height of 6 feet. But since it is a pyramid, divide by 3. Giving us a volume of 401.92 cubic feet. So that'll give us a total volume, if we add those together, $4,421.12 cubic feet. There's our total volume. So volume, like I said, is strictly additive, meaning I just find the volume of each of the components and add them together. Surface area is not strictly additive. What I mean by that is I can't find the surface area of the cylinder and the surface area of the cone and just add them together. Because when you put compound shapes together, there has to be two surfaces that come together. So it has to cover up at least one surface on each of those objects. So when I do piece 1 here, which will be the cylinder, even though a cylinder has two bases, I'm only going to use the area of the base once. The reason being is this base up here is not exposed. It's covered by that cone. So it's not on the surface anymore. The term surface means it's exposed or out where it can be seen. That one's covered up. So we take that out. We don't count that anymore. For our lateral area, we'll find the perimeter of that base, which is just pi times 16 feet, otherwise known as 50.24 feet. And that is a regular shape. Even though we didn't count the surface area of the other circle, it is a circle on both ends. So that is just the perimeter of the base. times the height. So what is that? 1,004.8, I believe, square feet. So those are the components for piece 1. That adds up to 1,205.76 square feet of surface area for piece 1. For piece 2, normally I would start with the area of a base. But again, the base of that cone is up against the cylinder. It's not exposed. It's not on the surface. So I'm not going to count the area of that base. It's covered up. So the only part of that cone that is exposed, the lateral area. We still need the perimeter of that base. Well, it's the same circle we had up here, so it's 50.24 feet. But we need to know the slant. So this is 6 feet here. Half of the 16 makes this 8 feet. You've got 6 squared plus 8 squared equals that slant squared. I will let you figure out and confirm a 6, 8, 10 is actually a standard, common standard right triangle. I'll let you go through the math to confirm 30, 6 squared is 36, 8 squared is 64, that's 100, square root is 10. So that slant is 10 feet. So the lateral area here is the perimeter of that base, 50.24 feet, times the slant of 10 feet, divided by 2 because it's a cone, so it comes to a triangle, which is 256 point 251.20, I believe, square feet. Let me try that. 251.2, good. So that's the surface area of the exposed portion of the cone. We add that up to get total surface area. (1,456.96 square feet). Any questions? Is there anybody confused as to why I left parts off of that surface area? Like I said, that is the tricky part. The volume is pretty easy because you just find the volumes as usual and add them together. The surface area, you've got to figure out what surfaces are covered so that you don't have to count those. Our last thing for today, pretend that looks like a ball or a sphere. A sphere has only one surface. It has no bases. The only defining characteristics of a sphere are the location of its center and the length of its radius. That's it. And of course, if it's a moving sphere, if it's not located with a fixed center, all it really has is its radius. It's the only dimension that defines a sphere at all. So let's say we have a 6-inch radius on our sphere here. The volume of a sphere is 4/3 times pi times the radius cubed. The 4/3 again is a constant that comes from calculus. When you take a circle into 3 dimensions, you have to cube the radius, but that 4/3 is a constant that adjusts that for volume. So for this sphere here, the volume is 4/3 times pi times 6 is my radius cubed. So I don't have to use the fraction. I just do 4 divided by 3 times pi times 6 cubed. Okay, 904.32. And that was in inches, so this will be in cubic inches of volume. Surface area. The formula for the surface area of a sphere, it's 4 times pi times the radius squared. Again, that 4 is a constant that comes from calculus. It's kind of neat that it actually does work out. That's exactly 4 circles of that radius that it would take to cover the surface of a sphere with that radius. So for this sphere, that's 4. The surface area is 4 times pi times that radius of 6 squared. Which I believe that comes out to 452.16. Let's try it just to be sure. It is 452.16 square inches. Now that you have those formulas, I want to see what you can do with them. This one is similar to the last example we did up there with the cylinder with a pyramid on top. This one is a cylinder with a half sphere on top. So we're going to go 20 inches is the height of the cylinder. We're going to go 24 inches is the total height. I want to see if you can find volume and surface area. I'll give you a few minutes. We'll go over this in about 3 or 4 minutes and see how you've done. Let's take a look and see how you've done so far on. So for volume, I'm going to break it up into two pieces. Piece 1 is going to be the cylinder. Piece 2 will be that half sphere. So for the cylinder, I have to find the area of a base, which will be pi times 4 squared, or 50.24 square inches. So that volume will just be the 50.24 square inches times the height of 20 inches, which is what, 1004.8 cubic inches. So that is for the cylinder. For the half sphere, the volume is just 4/3 times pi times that radius of 4 cubed, but it's only half a sphere, so I'm going to divide that in two. So we enter 4 divided by 3 times pi times 4 to the power of 3 divided by 2. We'll get 133.97 cubic inches. So we add those up to get a total volume of 1,138.77 cubic inches is our volume. Any questions on the volume? For surface area, well, for the cylinder, we know the area of the base. This will be for piece 1 again. The area of the base is 50.24. Once again, just like the example with the cone, this top one is covered up, so we don't need to count that one. We just need the bottom one. For lateral area, We need the perimeter of the base. Which is pi times 8, because it's 8-inch diameter, 4-inch radius, is 25.12 inches. So the lateral area here, 25.12 inches times that height of 20 inches. No dividing by 2 or anything like that, because these are straight up the sides. This is a regular solid, circle on bottom, circle on top. It's a rectangle, so there's no dividing by 2 or anything like that. So that is 502.4 just squared. So let's add those two pieces up. Okay, surface area on the exposed part of the cylinder, remember that's the cylinder without the one base that's covered up, is 552.64 square inches. Now then we have the second piece, is our half cylinder, or half sphere, I should say. That half sphere has surface area of 4 times pi times the radius, which is 4 squared, divided by 2 because it's half a sphere. I believe that is 100.48, but I'm going to double check here. Oh, that didn't work. Let's try that again. It is 100.48 square inches of surface area for the half sphere. So we add that all together. I don't know what happened there. It's 653.12 square inches of surface area. Out of that packet from last week, that big packet that was out there, pages 179 through 194, do any of those gray boxes. So the gray boxes in there have homework, have problems in them. Do the odds, of course, in those gray boxes. And then in the big book, it is page 706, exercise 28-2. You just want to do the odds there as well. And then don't forget, you do have those 3 quizzes looming out there. You got the quiz on the calipers and micrometers. You have the quiz 10 for both, and a quiz 10 for apps that are out there to be done. The good news is we're 6 weeks through the course. Over a third of the way there. So it sounds like I'll actually get to be in the room with you guys at least a couple days a week in the spring, so that'll make things a little easier. Well, yeah, hopefully. So far, that's the plan. I am actually still